Okay, so what we're going to do here is we're going to work on the difference quotient, and we're going to work on the difference quotient for the function f of x is equal to negative x squared plus 5x plus 7. And we're going to have the difference quotient, of course, is equal to f of x plus h minus f of x divided by h. Now, the first thing I'm going to do is find f of x plus h. And for that, anywhere I see an x in this function definition up here, I'm going to replace by f of x. I'm going to place by x plus h. So it's going to be f of not x, but x plus h is equal to negative not x, but x plus h squared plus 5 times not x, but x plus h plus 7. Now now this is f of x plus h, but I'm going to have to simplify it to get this problem to work out the way I want to. So I'm going to note that this is going to be negative. Now x plus h squared is the square of the first term, which is x, plus 2 times the first term, which is x, times the second term, plus the square of the last term, which is h squared. Now I can distribute the 5 to the x and to the h. So it's going to be 5x plus 5h, and we have a 7 over here. And lastly, I can just distribute the negative sign to each of these, so it's going to be minus x squared minus 2xh minus h squared plus 5x plus 5h plus 7. Great. Okay. Now the next thing I want to calculate is not f of x, but negative f of x. And f of x is just equal to negative x squared plus 5x plus 7. But I'm going to stick a negative over here, and because I do that, I want to stick a negative over here. So this is going to be equal to, if I distribute the negative sign, a negative and a negative x squared is a positive x squared. A negative and a 5x is a minus 5x. And a minus and a positive 7 is a minus 7. So f of x plus h minus f of x is just going to be this guy up here, which is going to be negative x squared minus 2xh minus h squared plus 5x plus 5h plus 7. And I'm just going to write the minus f of x beneath it. And minus f of x is going to be x squared. And I'll write the minus 5x over here. And I'll put the negative 7 over here. And I can do that because I found negative f of x instead of f of x. So all the signs are already correct. So I can just write them out like so. And these guys cancel out to give me 0. These guys cancel out. And these guys cancel out. And I wind up with negative 2xh minus h squared plus 5h. And I'll just bring this down. Okay? So we have this over here, f of x plus h minus f of x is equal to this. But the difference quotient means everything has to be divided by h. And that's the difference quotient, but I can simplify this. And for that, I'm going to go on to another page. And that'll be my last step. I almost had enough room to do this problem. But I guess I'm going on to another page, so, well, so be it, right? Okay. Okay, so we have, from the previous page, we have f of x plus h minus f of x divided by h is equal to negative 2xh minus h squared plus 5h divided by h. Now what I'm going to note is each of these terms has an h in common, so I can factor the h out. So this becomes h times negative 2x minus h plus 5 divided by h, right? Because you'll notice h times negative 2x is negative 2xh, h times negative h is negative h squared, h times 5 is 5h, so I could factor that out. Now what I do is I can cancel this h with this h because h is not 0 as part of the definition for the difference quotient, and we wind up with this is equal to negative 2x minus h plus 5. And that's my answer. Now, if we were doing a calculus course, this is actually one of the first things you'd have to be comfortable with. And we would do one more step, is we would say let h equals go to 0 now. H is not 0, but say we were to let it just go to 0. Say h is moving. Just let it go to 0. Then we would say that this difference quotient approaches negative 2x plus 5. And that would be called the derivative of the function f of x is equal to negative x squared plus 5x plus 7. And this is a formula for finding the slope of a curve at a particular point. You don't need to know that. This is as far as you have to go. But if you're wondering why we do this, and the idea is if, now that we're done with the problem, I'll just go on a slight tangent because there's no loss now, except for video time, and have plenty of hard drive space. So we have the point x, and it's the corresponding y-coordinate on the function, the x-coordinate and the y-coordinate, and we have, say, x plus h, and f of x plus h. So we have this point and this point, and if you calculate the slope between these 2 points, the difference y1 minus y2 is f of x plus h minus f of x, and x2 minus x1 is x plus h minus x. The x's cancel, and I wind up with f of x plus h minus f of x divided by h, which is my difference quotient. Now, what we end up doing is asking what happens when h goes to 0. Okay, this is similar to what Isaac Newton was trying to figure out, because the whole idea is if we have a curve or something, we would want to know if we were to draw a line right past this point over here that touches the curve right at that point, what is the slope of that line? So if we had some object or some car that had this type of path, or if this was, say, time and this was distance, then the slope is velocity, and a car that was decreasing in distance over here, increasing in distance like this with respect to time, you might want to know how fast is the car going at this particular point. And it would be the same as a line moving like so was the idea. And that's essentially what the derivative tells you. If this is, and that's as far as I'll go not to confuse anyone, but the way you would do it is you would say this is your point x, and say this is your point x plus h, and you would draw this line over here, which you can calculate, and as you let this point move closer to this point, the lines are going to get steeper. Your next line would be like this, this, and eventually you wind up with this line over here. And that would be called your derivative. So, anyway, that's all I have to say for that one. So I hope you're all inspired to go take a calculus course now. But I hope you have a great day, and I hope to hear some more questions for you.